Hi everybody, and welcome to the second video for the course. In this video we continue the trajectory we began last time. So we continue the thread of numeric data types and things you can do with them. So we'll build on the arithmetic we did last time. Before we jump into it though, if you need a pick-me-up for your day, here's a picture of my baby son looking extremely pleased with himself. Okay, so I told him to look at Dad and smile, and he did. Very cooperative that day. Okay, so let me just start by recalling what we did last time. We defined the data types int, long, float, and double, 4 different numeric data types for storing numbers. Int and long were for storing whole numbers. Float and double were for storing decimals. And then I just pointed out that addition, subtraction, and multiplication work like you expect them to. You know, the computer knows what those operations are. You do not need to teach C++ what the plus symbol means or the minus symbol means. That's built in. So this time we'll just pick up that thread and I'll talk about various other operations like division, for example. C++ can certainly do division, although there is some subtlety to it that we will discuss. An operation called modular reduction, which means nothing to you right now, most likely, but I will explain what that is. And then various mathy other things like square roots and powers, things like this. Okay, so let's begin with equation overriding. So if you ever want to take and update a variable using the old value of the variable, so an equation like this, for example, what's happening is if the old value of a is 7, then this equation is acting like the equations from the last video, where this is an assignment equals. So whenever you have variable equals stuff, whatever is on the right-hand side here gets placed into the left-hand side. So the value of this variable becomes whatever this value is over here. So if a has value 7, then what you're saying is take 7, add 1 to it, now the value is 8. Take 8 and place it inside that storage space. So this line of code is simply taking the value of a and upping it by 1. And same thing for something like this. A equals a minus 1. You're taking the value of a and knocking it down by 1. This equation, this line of code, can be shortened to this, a plus plus. That just means increase the value of a by 1. A equals a minus 1 can be shortened to a minus minus. So just to demonstrate this, let me get a variable going. Let's say that a is 7. A plus plus, that line of code, is supposed to increase the value of a by 1. Let's just make sure that it does. The computer printed 8, right? So it worked. And you can do this as many times as you want. So let me do it 3 times. So now what's happening is, originally a has value 7, then the value of a becomes 8, then 9, then 10, right? Each time you write this line of code, you are upping the value of a by 1. So 10 is what should get printed here, and it does. Notice these 3 lines of code are kind of obnoxious to write them all. You could just do something like this, right? A equals a plus 3. So instead of doing increase by 1, increase by 1, increase by 1, just increase by 3. So that will do the same thing. The computer should still print 10, and it does. So minus minus works the same way. Okay, now let's talk about division. So, the computer knows how to divide, just like it knows how to multiply or add. You don't have to teach it that. It's just that when you're dividing 2 whole numbers, there's a sticking point. There's a subtlety to it that you need to be aware of. And the subtlety is that the computer will do what is called integer division. So before I explain what that is, let me just warn you, you will be annoyed by this during the semester, probably multiple times. Okay, you just have to get used to this. So you will have probably a couple of programs that don't work the way you want it to because you forget that this is what C++ is doing. Okay, so let me show you what I mean by integer division. Let's ask the computer what it thinks 4 divided by 2 is. Okay, let's start like that. So the slash symbol like always, regardless of C++, that means divide. So this is just saying print to the screen what you think 4 divided by 2 is. And if the computer knows what division is, it should of course print 2. Right? 4 divided by 2 is 2. Okay, nothing surprising there. Let me change the 4 to a 5. And now we all know, right, 5 divided by 2 is 2.5. So what the computer should print to the screen is 2.5. But notice it doesn't. It prints 2 to the screen. Okay, that's strange. Just to show you this isn't a fluke, let's do a couple of different divisions. 8 divided by 4, we all know is 2. No issue there. Okay, what about 11 divided by 4? That is 2.75. So if the computer is doing this division, it should print 2.75, but it doesn't. Okay, the computer prints 2 again. So what's happening here is that the computer is just forgetting about the decimal part of these numbers, right? It should print 2.75, but it just forgets that there's a 0.75 there. Should print 2.5, but forgets there's a 0.5 there. The reason it's forgetting about the decimal part is that you are giving the computer an integer or whole number, right, divided by another integer. And whenever you do that, when you hand it 2 integers, the computer thinks that you want an integer back. It thinks that you want the result to be another integer, right? So when you hand it 11, which is a whole number, and 4, which is another whole number, the computer thinks that you are living in the land of whole numbers, and that's where you want to stay. Okay, so that's what's meant by integer division. If you divide 2 integers, the computer will give you an integer back. That is, generally speaking, a problem because, as you all know, when you divide 2 integers, you don't necessarily get an integer back. So how do you force the computer to give you the actual division? Well, the answer is what it says here in the slide. Float cast is the technical term. There are 2 ways to do that. Here's one way. Instead of writing 11, you can write 11.0. So what you're doing there is you are telling the computer, I don't want you to think of 11 as a number, a whole number. I want you to think of 11 as a decimal. Okay, then the computer's like, oh, he gave me decimal divided by number or whatever, right? So I'm allowed to give a decimal back. So now it behaves properly, right? So same thing with, what was my original example? 4 divided by 2. If you do 4.0 divided by 2, sorry, not 4, 5. 5.0 divided by 2, it gives you 2.5 now, right? And by the way, it doesn't matter which of the numbers you cast to float, so you can tell it either the numerator or the denominator is a decimal, and it will respect that. All that matters is you can't have both spots be integers. Otherwise, it will give you an integer back. Okay, so that's one way you can cast a float. For the other way, let me just get a couple of other variables going. So let's say that y is 5 and x is 2. Okay, then I want the computer to output y divided by x. So it's still 5 halves, right? It's not doing anything special. It's just that when you have variables going, you can't do the trick I just did. You can't write 0.0. The computer has no idea what that means, right? It won't run, okay? So since you can't do that 0.0 trick, you do this. Parenthetically, right? So it's like an aside to the computer. Oh, by the way, I want you to think of y here not as an integer, how it's declared, right? But think of it as a float for now, right? So y is an integer, but computer, when you're doing this division, think of it as a decimal. And now it gives you 2.5, right? And as with the 0.0 trick, you can do that to either the top or the bottom of the fraction, and it will respect that you want the actual division. Okay, so anyway, so that's how division works in C++. If you divide 2 whole numbers, you have to float cast if you want the actual division back. Let's now move on to what's called modular reduction. This operation takes getting used to, okay? I will warn you ahead of time. Not only does it take getting used to, but it's not at all clear why it's useful once you understand what it is, okay? So by the end of this video, I hope that you are at least comfortable with this percentage symbol operation. We will see throughout the course why this operation is useful, okay? But let me just admit up front, it's not clear why this operation is useful, but it certainly will be as we move through the course. So a percentage b, so percentage is like a multiplication symbol or division symbol. It's just another symbol for something you can do to two numbers. How does it work? The way it works is you take the number a, divide by b, and then you record the remainder of that operation. Okay? So a percentage b is the remainder when you take a and divide by b. So think about 4 percentage 2. Okay? If you take 4 and divide by 2, there's no remainder. Okay? 2 goes into 4 evenly. 4 divided by 2 is 2. Full stop, right? No remainder. So 4 percentage 2 is 0. 5 percentage 2, though, if you take 5 and divide by 2, there's 1 left over, isn't there? So 5 percentage 2 is 1. Okay? So a percentage b is a remainder. It's actually kind of the complement to integer division. Okay? Because what is integer division doing? Basically, it does the division and forgets about the remainder, right? Because it just chops off the decimal piece. A percentage b remembers only the decimal piece, essentially, right? Remembers only the remainder. So a consequence of this is that a percentage b is 0, if and only if b goes into a, right, evenly. So a is a multiple of b. So 4 percentage 2 is 0. Why? Because 4 is a multiple of 2, right? 5 percentage 2 is not 0, because 5 is not a multiple of 2. So this fact, actually, it's not clear why that's useful, but it will be useful for several of the programs throughout the course. So let me just go to the compiler and let's mess with this a little bit. So let's have an x and y, and let's say that, I don't know, y is 7, and x, or sorry, let me do this alphabetically. X is 7, and y is 3, okay? And let's say that z is x percentage y. Okay. I'm going to ask the computer, oops, it's yelling at me because I didn't create z, right? Okay. So I'm going to ask the computer what it thinks z is here in a second, but let's think it through. What should z be? When I take 7 and divide by 3, what I get is 2 1/3, right? So 6 is a multiple of 3, right? 3 goes into 6. It takes 1 more to get up to 7. So when you take 7 and divide by 3, the remainder is 1. And notice it prints to the screen 1. If x is, say, 9, well, 9 is a multiple of 3. So when you divide 9 by 3, you get no remainder. Right, computer? Yeah, I don't know why it didn't show it first, right? But 0. There's no remainder when you divide 9 by 3. Okay, that's how that operation works. So again, it takes some getting used to. So finally, to conclude this video, if you want to do things like take roots, take powers in general, you need a cmath package. And so let me show you how that works. Packages are things that are written up here. And so basically, what you're doing is you are plugging into a pre-existing library, in this case called cmath. This IOStream package up here, what that does is that plugs into a package where the computer has already been taught what cout means, for example, or what cin means, you know. So if you didn't have this up top, the computer would have no idea what cout means. So somebody previous to us, right, has built a package that lets the computer know what cout means. So same thing with this. Somebody has taught the computer what square root is or what powers are, you know, and when you plug into this package, you can now use all of that. So let me clear this out. Okay, so for example, suppose you want to know what the square root of 2 is. You can use this command, squirt, square root, and print it to the screen. So the thing is, inside of cmath, somebody has taught the computer what sqrt means, square root. And you know, 1.4142 is approximately the square root of 2. The square root of 9 is 3. So what should happen here is 3, right? Now if I get rid of this, so I'm not plugging into that previous package, The computer doesn't know what to do. It doesn't recognize that SQRT line. So no. Okay, but with that package there, the computer knows what I'm talking about. So anyway, so you can take square roots using this package using the SQRT command. You can also take more general powers using this command. It's kind of obnoxious though, because suppose you want the computer to print to the screen 3 to the 4th. You would most likely write that, wouldn't you? Right? I mean, this little caret symbol usually means take to the power of, please, right? So 3 to the 4th. But notice if I try to run that, the computer still runs it, but it's confused, okay? 3 to the 4th is not 3, I think we all agree. 3 to the 4th is 81. So what the computer basically does is, it says, I'm confused by this thing here. I will ignore it, right? And just give you a 3. I guess is what it's doing. I'm not totally sure. But at the very least, it's not working properly. So this is also obnoxious, but the people who created C++ did not teach the language what caret means. They did something slightly more convoluted. If you want to raise 3 to the 4th power, you have to use a command like this. Pow for power, and then you give it the first number, and then give it its exponent. So this stands for 3 to the 4th. 81. Okay, so now it knows. Okay, so that's how powers work, unfortunately, right? You can't just do 2 caret 3. You would have to do 2 cubed, like this. And then it gives you 8. Okay, so to wrap up this video, let's use some of this in a program. So here's the example program for today. Let's write a program that lets the user give us the volume of the sphere. And what the program does is it calculates and then prints to the screen the radius of the sphere. Okay, so you give it a volume, the computer gives you back a radius. So if this were assigned to you for homework, the first thing you should do, if you don't know this already, is go to Google and ask it what the volume of a sphere is. Okay, because you of course don't have to know that off the top of your head. This is what Google will give you. This is the volume of a sphere formula. So this is how volume and radius are related. So what does our program look like? Well, first of all, if the user is going to hand us a volume, we must create a storage space for it. Okay, so we have to create a variable for it, just like in the last video. We ask the user for the volume, and we store it. Then, we have to take this equation here. If you want the radius from the volume, you have to isolate the radius just like you would in an algebra course. So, you multiply by 3, you divide by 4 pi, you take a cube root. That's how you isolate that r. So multiply by 3, divide by 4 pi, take the cube root, is what it says here, right? And then we know what r is, and we can print that to the screen. So let's walk through that here. Let's create a couple of variables. So first, the user is going to give us a volume. Let's just say for now we know that the volume will be a whole number. That's what we are expecting from the user. We need another storage space for radius. Let me just point out though that there's something slightly off about what I just wrote. Okay, if the volume is a whole number, well, how do we find the radius? We find the radius by multiplying by 3, dividing by 4 pi, taking a cube root. Okay. There's absolutely no reason to think that we will get a whole number back at the end of that process, okay? If you start dividing by 4 pi, right, you are most likely not going to get a whole number back. So even if the volume is an integer, the radius will most likely be a decimal. So as I mentioned in the previous video, when you're declaring variables, you have to think about what kind of thing they will be, and sometimes that's dictated by previous stuff, right? If you know you are getting this radius from a volume that was handed to you, the radius needs to be a decimal. Okay, so now we ask the user for the volume. We get the volume. Okay, now what's the radius? The radius is, well, what did we say? We said we took the volume and multiplied by 3, right? Volume multiplied by 3. We take the result and we multiply by 4 times pi, which we'll just write 3.1415 for now. That's approximately pi, okay? So we multiply by 3, divide by 4 pi. Oh, and then we're supposed to take the cube root of all that, aren't we? And the way that you can take a cube root, recall, if you don't remember, that cube root is the same thing as taking to a power of a third. So here we go. Volume has been multiplied by 3, divided by 4 pi, and the result of that you will take to the 1/3 power. That's how you can find a radius. So if we were in class and I were looking at you, I would ask you, well, first of all, if you understand this, right? But also, if you think about stuff we talked about previously, about 10 minutes ago, this should look suspicious to you. Okay, 1 is a whole number, 3 is a whole number. So 1/3 for the computer right now is a whole number, right? So what we actually want is literally 1/3. So let me think about it like that. And then when we're done, we will give the radius back. So let's just run this and see what it does. Let's say the volume is 10. It tells me the radius is 1.33652. Okay, once you run a program and you get an answer like this, you should always check. You know, there's always a possibility you made a mistake inside of this code. So let's see if that's a reasonable answer, 1.33652. Okay, so the volume of a sphere is 4/3 times pi, which we were thinking of as 3.1415, times radius cubed. So here's 4/3 pi r cubed, and look, it's basically 10, right? Which was the volume we handed it. So we have pretty good evidence now that this program is working the way it's supposed to. Okay, so at the end of this video, you should be comfortable with lines of code like this, A++. You should be comfortable with division and the subtlety that comes with it, right? Integer division. You should be somewhat comfortable with this percentage operation, this modular reduction operation, although it takes getting used to. And if I ask you to, you should be able to handle taking the square root or taking any general power of a variable or a number using the cmath package, right? So putting this guy up top. Okay, so that concludes this video.